In this video we are going to focus on volume and capacity as part of the topic on surface areas and volumes of three-dimensional objects. In the previous video we focused more on surface area, now we are going to focus on volume and capacity. So firstly, what is volume? It is how much space a solid occupies. Usually when I think of volume, I think of, let's say if we focus on this container, how much it can contain. Whereas so basically with how much can we fill up this container. If on the other hand it was surface area, I would ask how much paper do I need to wrap this around this shape or this container in square units. Okay, but volume is how much can it contain. So it's about the inside, whereas surface area is about the outside. So now that we know that volume is the formula for the volume of a cuboid, before we get there, the volume is the area of the base of a prism. So if we look at this box, we have congruent bases. So the top is a rectangle, the bottom is a rectangle. So if we take the area of that and then multiply with the perpendicular height, then we will get the volume. So in general, volume, the area of the base of the prism times the perpendicular height. So if we now look at a cuboid, and this is a cuboid, we know the area of the base, and the base is at the top and the bottom, is a rectangle, so it's the length times the width. So that's the area of the base, and then we still have to multiply by the perpendicular height, which is h. So that is the perpendicular height part. So therefore we can simplify it to length times width times height. So we already shown this one. So now the formula for the volume of a cube. Okay, so remember in general we first need the base or the area of the base. In this case we have a square base at the top and the bottom, and now we know for a square length times width, length and width rather, are equal. So we could say we actually have length times length. So that's the area of the base. And then we still have to multiply by the perpendicular height. So for a cube it will also be the length, as all the sides are the same length. So for a cube, if we simplify, length times length times length is the same as length to the power 3. So now if you look at the triangle, we first want the area of the base. In this case we will have triangular bases. So we know for a triangle the area is the half times the base times the height. So that's the area of the base. And then we still have to multiply by the perpendicular height. In this case we use a big H for the perpendicular height, as we already used the small h for the perpendicular height of the base, whereas this is the perpendicular height of the whole shape. That's why it's the big H. So now we can simplify because we know multiply is the same as just writing letters next to each other. So it's half b times small h times big H. So now that we went through the basic formulas, let's apply them by using exercise 17.2 to illustrate. So firstly, we have to calculate the volume of each of these solids. Solids, remember, means three-dimensional figure, correct to 3 decimal places. So firstly, we need to identify what kind of solid we have. So in this case, let's just look. We have different lengths for all the sides. So this must therefore be a rectangular base. So we know for the base we need the length times the width. So the length is 29 and the width is 13 centimeters, whereas the height, perpendicular height, is 6 centimeters. So this is the length and this is the width. So therefore volume is area of base times perpendicular height. So volume is therefore equal to length times width. That's the area of the base, and then we still have to multiply by the height. Okay, this is actually small h, big H we use when we have a triangular prism. So now it's a simple matter of replacing or substituting. So length is 29 centimeters. Width we can replace with the 13 centimeter. And height we can replace with the 6 centimeter. So now it's a matter of using the calculator. So what is 29 times 13 times 6? So we have 29 times 13 times 6, which will give us 2,262. And now centimeter times centimeter times centimeter is centimeter to the power 3. So we have cube centimeter. So when we deal with surface area, we work with square units. When we work with volume, we work with cube units. Okay, so now let's have a look at number C. So it seems we again have a rectangular prism. If we look at the base, we have 37 meter and then we have 19 meter for the width. So 37 meter is the length, 19 meter is the width, and then the perpendicular height is 8,5 meter. But now what we see in this case, there's a small block cut out with dimensions of 2,5 all around. So this is in fact a cube that is cut out of the cuboid. So the big shape is a cuboid, and out of that cuboid we cut a little cube. So we will have to calculate the area of the whole cuboid and then subtract the small area of the cube. So let's calculate the volume. I said area, volume. We have to take the volume of the cuboid and subtract the volume of the small cube. So the volume we now know is firstly the area. Okay, so let's just write this first as volume equals volume of cuboid minus volume of the cube. Okay, now we know we first need to take the area of the base, so we have length times width, and then we still have to multiply by the perpendicular height, so it's the height minus for the cube, the small cube, we have the area is the length times the width, that's the area of the base, and then we still have the height, the perpendicular height. So again, it's length times width times height, but since it's a cube, actually all of these sides have the same length, so in fact it is L times L times L, so it's L to the third. So now it's a simple matter of substituting, so in the cuboid the length we can replace by 37 meter, the width we can replace by 19 meter, and then the perpendicular height we can replace by 8,5 meter. So now we have everything for the cuboid. Let's subtract the small cube, the volume of that, so it's the length, which is 2,5 meter to the power 3. So now it's a matter of using your calculators. So we have 37 times 19 times 8,5, which results in 5,975,5. Meter times meter times meter is meter to the 3, minus 2,5 times 2,5 times 2,5, or 2,5 to the power 3 is 15,625 meter to the power 3. Now it's a matter of subtracting. Which results in a final answer of 5,959,875 cube meter, and it is to 3 decimal places. Okay, so number 3, we have a cuboid that has a width of 1,5 meter. So we know the width is 1,5 meter, the height is 0,7 meter, has the same volume as a cube that has a side length of 1,4 meter. Calculate the length of the cuboid in meters correct to the nearest millimeter. Okay, so let's first think of our cuboid. So cuboid, to calculate the volume of that cuboid, we know we first take the area of the base. So the base in this case is a rectangle. So if you know what a cuboid is, you know it's a rectangular prism. So for rectangle, the area of that base is length times width, and then we know we still have to multiply by the perpendicular height. So now let's substitute. So we don't know the length. We do know the width, it's 1,5 meter. And we do know the height, it is 0,7 meter. We don't know the length, so that we still have to calculate. We also don't know at this stage the volume of the cuboid, other than it has the same volume as a cube that has a side length of 1,4. So let's therefore calculate the volume of the cube first, because whatever that volume is, we have to replace the cuboid with that volume as it's the same. So for a cube, we know all the sides have the same length, so it's simply length to the power 3, because the area is length times length, which is length squared, and then we still have to multiply, in fact, with the height, which is the same as the length, so it's L to the power 3. So now they give us the length, it's 1,4 meter. So we have to cube that. So what is 1,4 times 1,4 times 1,4, or 1,4 to the power 3? Yes, it's 2,744 meter cube, or cube meter. So therefore we can now replace the volume of the cuboid with 2,744, as that is the cube meters. So we therefore have that 2,744 equals, what is 1,5 times 0,7? Okay, this is cube meter. Eh? Okay, so let's see. This we can also say is L meter. So we have 1,5 times 0,7, which is 1.05. Meter times meter times meter is cube meter. But remember, there's still an L, eh? We still have to multiply that 1,05 with the L, because that's the missing one that we are looking for. So now we simply want L. We don't want 1,05 Lm cubed. So we will have to divide by 1,05 cube meter to cancel everything except the L. Remember, letters standing and numbers standing next to each other simply means multiply by convention. So what we do to the right, we will have to do to the left. So now we will get our answer to L. So the cube meters may cancel, so now we simply have to divide 2,744 by 1,05. So 2,744 divided by 1.05 will result in 2,613 meter to 3 decimal places. Okay, but we need to the nearest millimeter. Millimeter. Okay, so we still have some work to do. Okay, so let's see. Firstly, 1 meter is how many centimeter in a meter? Yes, 100 centimeters in a meter. So 1 meter is equal to 100 centimeters. So now the thing is, how many? Yeah. Okay, so we can replace. So let's first do that. So therefore we can say in the place of the meter, we can insert centimeters. 100 centimeters. So we have 2,613 replace meter by 100 centimeter. Okay, so this is still L. So now we can jump the comma 2 places to the right as we multiply, and we have 2 zeros, we jump to the right. So it becomes 261,3 centimeter. Now the next question is 1 centimeter is equal to how many millimeters? Yes, 10 millimeters. So we can now replace centimeter with 10 millimeters. So we have 261,3 in the place of centimeter, 10 millimeter. So we multiply 1 0, so we have to jump the comma once to the right, so it becomes 2,613 millimeter. So this is to the nearest millimeter. So that's the length of our missing side of the cuboid. Okay, so now number 2, we have a wall that is 4 meter long, 2,8 meter high, and 16 centimeter wide. Okay, so here one of the first problems that we see is we have centimeters versus meter. So we will have to do something there. An opening that measures 80 centimeter wide by 2 meter high has been left for a doorway. Calculate the volume of the wall correct to 3 decimal places. Okay, so let's just maybe draw a wall and the doorway. Okay, so it's 2,8 meter high and it's 4 meter long and it is 16 centimeter wide. Okay, so we know the width is 16 centimeter. So that's like, I just drew now in 2 dimensions. Let's just maybe draw a 3rd dimension in here. So it is like 16 centimeters wide. Okay, so that's like the thickness of the wall. Okay, an opening that measures 80 centimeter wide by 2 meters high, so it actually didn't go to the top, the door, there obviously is a bit of space. So we have 2 meters in height. $80 centimeter wide, so this distance is 80 centimeters. Okay, and obviously it will have the same thickness of the wall, so it will also have the 16 centimeter as the thickness, so, or the width. Okay, so now we can tackle this problem. So basically what we have to do is we see we have a rectangular shape. We have to calculate the volume of the rectangular shape, in other words the cuboid, and then the smaller rectangular one, we will have to get that volume and subtract it. So we have basically the volume of the big, well, let's just say volume is volume of big minus volume of small. Okay, so now the other thing is we need to get our units the same. So we need to either work with meters or we have to work with centimeters. We know 1 meter is equal to 100 centimeters. Okay, so let's work with meters. You could have worked in centimeters, you should get in the end the same answer. So I have less units to convert from centimeter to meter, because I only have to convert 1, 2. Whereas if I had to convert from meter to centimeter, it would be 1, 2, 3. Okay, so there are definitely more. Okay, so therefore 16 centimeter, if we want the ons in meter, there are many centimeters in a meter, so therefore the ons of meter must be small, so we will have to divide by 100. Or we could simply say 1 centimeter. To just get 1 centimeter, we have to divide the right by 100. What we do to the right, we do to the left. Now these hundreds cancel out, so we can replace centimeter by 1 over 100, meaning we are actually dividing by 100. So 16 centimeter is the same as, okay, remember we have now a comma 0, we divide, the comma jumps 2 spots to the left. So 1's 2 in front of the 1, so it's 0,16 meter. Okay, similarly we could show that this 80 centimeter is 0,8 meter. So now we are ready to replace. So first the big one. So we know for a cuboid, we have the area of a rectangle, which is length times width, and then we still have to multiply by the perpendicular height. The same will apply for the small one, as it is also a rectangular shape, or a cuboid. It's just a smaller one. Okay, so now first the big one. We know the length is 4 meter, so we can replace length by 4 meter. We know the width is now 0,16 meter. And the height is 2,8 meter. And then we still have to subtract the smaller one. So the length for the smaller one is the 2 meter. Well, the 2 meters is actually the height, so we actually have the 80 centimeter, which is 0,8 meter. The width will be exactly the same. It's the 0,16 meter. It's like the thickness of the wall. And then the height is the 2 meters. So now it's simply a matter of getting our calculators out and doing the calculations. So we have 4 times 0.16 times 2,8, which is 1,792 cube meter. We have to subtract the smaller one's volume, 0,8 times 0,16 times 2, which is 0,256 cube meter. So that we can now subtract from 1,792 2, and we end up with an answer of 1,536 cube meter to 3 decimal places. Yeah, so the tough part actually with this one was to notice that they don't give you the thickness or width. That's why I actually sketched a picture of this. You should actually use your common sense to determine that 0,16 you have to use for both the big as well as the small cuboid. So your task is to attempt number 1B of exercise 17.2.